All right, let's talk about something you probably have in your house right now. Go ahead, open up that medicine cabinet. Chances are you're going to find a bottle of aspirin. It's just always there, right? For headaches, for fevers. But inside that super common, everyday pill is a chemical story that is way more complex and, frankly, way more dangerous than you might think.
I mean, this stuff has been around forever. We're talking ancient civilizations using willow bark for pain relief. But then, in 1899, the company Bayer figured out how to synthesize it, package it, and sell it as the little white pill we all know. It was a total game changer, a legitimate wonder drug.
But here's the twist. What happens when the dose is too high? When this thing we trust, this staple of modern medicine, completely overwhelms the body and turns into a flat-out toxin? Well, that's exactly what we're about to get into.
Now, part of what makes this so dangerous is that the first signs of poisoning are super deceptive. Seriously, it doesn't look like what you'd imagine a classic overdose would look like at all.
So picture this. A patient comes into the ER. They're not passed out. They're not acting crazy. The one really big, glaring thing you notice is their breathing. They are breathing incredibly fast and super deep, kind of like they just ran a marathon, but they've been sitting perfectly still.
And here's the thing. It has nothing to do with their lungs. The patient isn't actually short of breath. What's happening is the salicylates have gone straight to the command center in the brainstem, and they've hijacked the controls. They're basically screaming at the lungs to work, work, work for absolutely no good reason.
And all that unnecessary heavy breathing, it starts to seriously mess with the body's chemistry. You see, all that exhaling is getting rid of tons of carbon dioxide, which is acidic. So the patient's blood pH starts to climb, and it becomes alkaline. This first stage is called respiratory alkalosis, and it's the body's first and kind of weird response to the poison.
But that alkaline state, it's a temporary illusion. Because underneath the surface, something way more sinister is starting to take over.
To really get what's happening, we have to zoom way, way in, down to the cellular level. The salicylates get inside our cells, and they start to sabotage the mitochondria. You know, the little power plants that create all the energy for our body. They basically uncouple the whole energy-making process. The assembly line is still running like crazy, but it's not actually producing the final product, which is usable energy.
So what is this broken assembly line making instead of energy? Heat. Just massive, massive amounts of heat. The cells are burning through oxygen, but they're not making any power. They are literally burning up from the inside out, and that's why a high fever is such a terrifying sign in these patients.
And this is the tipping point. That initial alkaline state gets completely steamrolled by a flood of acid waste products from all those malfunctioning cells. The whole seesaw of the body's pH balance just comes crashing down hard on the other side.
And this acidic state, this acidemia, is where things get truly life-threatening. The acid in the blood lets more of that salicylate poison sneak past the blood-brain barrier. That leads to confusion, seizures, even a coma. It also poisons the heart muscle and can cause a total shutdown of the system.
So for the doctors in the ER, this is a race against the clock. And to make it even harder, the clues can be really, really misleading.
Now, you'd think, hey, just check the aspirin level in their blood, right? Well, it's not that simple. See this old chart, the Dunn nomogram? It's dangerously obsolete. A patient could have a salicylate level that this chart calls mild, but they could be on the verge of death. Why? Because the real danger isn't just the number, it's what that number is doing inside an acidic body.
Okay, so if you can't just rely on the blood level, how do you actually fight this? Well, you fight it with some incredibly clever and elegant chemistry.
The very first choice to make is about IV fluids, and this is a huge deal. If you give the patient normal saline, which is a super common IV fluid, you can actually add more acid to their system and make the whole situation worse.
The much better choice here is a fluid called lactated ringers, and the reason is pretty cool. The liver grabs the lactate from the fluid and chemically transforms it into bicarbonate, which is the body's own natural acid-fighting buffer. So you're not just giving fluids, you're giving the body the raw materials to fix itself.
But the real magic trick of the treatment comes from zeroing in on the main problem. Remember how the acid in the blood was letting the poison slip into the brain? That's because, in an acidic environment, the aspirin molecule is lipid-soluble. It's slippery. It can pass right through cell membranes like a ghost.
So the solution is just brilliantly simple. You do the exact opposite. You give the patient IV sodium bicarbonate to make their blood more alkaline.
And this forces the aspirin molecule to change its form. It becomes ionized or water-soluble. Now it can't slip through those fatty membranes anymore. It is effectively trapped in the bloodstream, where it can't get to the brain and do more damage.
And get this ion trapping trick, it works in the kidneys too. See, our kidneys are always filtering our blood. If the urine is acidic, the salicylate just gets reabsorbed right back into the body. But if you make the urine alkaline, that trapped ionized salicylate has nowhere to go but out. It gets flushed from the body.
And the effect this has is just staggering. I mean, look at these numbers. In acidic urine, it takes about 310 hours for the body to get rid of half the drug. That's almost 2 weeks. But when you make the urine alkaline, 4 hours. From 310 hours down to 4. That's not just a little better, that's a total game changer. It's honestly one of the most effective treatments in all of toxicology.
So, all of this brings us right back to where we started, that simple bottle in the medicine cabinet.
You know, aspirin has had such a wild journey. It went from an ancient folk remedy to a global wonder drug. And then, in the 1950s, it was actually a leading cause of accidental poisoning in kids. Now we understand it better. We know it's a powerful tool, but it's one that absolutely demands our respect.
It really makes you think, doesn't it? This one little mass-produced pill holds the power to take away pain and also the power to cause a complete cellular meltdown. It kind of makes you wonder, what other simple things in our lives are hiding that same kind of power, just waiting for us to understand them?